Chapter 4, it's mainly definition and terms with a lot of examples. I'm just going over some of the problems in this section because most of them, I think, if you read the lecture notes, you should probably understand. Like here is definition of event, simple event, sample examples. Like here, it's all the possibility when you flip a coin. When you flip a coin, there are two chances, right? You either get tail or head. So in that case, the chance is 1/2. Or when you're rolling a dice, you have 6 choices. 1, 2, 3, 4, 5, 6. So for instance, what's the probability of getting number 2? 1/6. Or when a baby is born, there are 2 possibilities, either boy or girl. Like what's the probability of getting a boy? 1/2. And then here is 3 type of method for finding probability. You have relative frequency, and I put examples here. Like in this case, based on number of times that he was successful, based on that, he decided about the probability. Okay. So now here we have a classical approach. In this type of event, all the outcome have equal chance of occurring. So when you're rolling a die, you get number 1, 2, 3, 4, 5, or 6. They all have the same chances of occurring. So for instance, like when I roll a die, what's the probability of getting 2? 1/6. And then we have subjective probability. This is when you're trying to estimate probability of rain tomorrow. It just depends on what part of the country do you live. So then I put some example here for you. So if you understand this example, that would probably tell you what type of probability do you have. Do you have relative, classical, or subjective probability? Now here we have this formula, and probability of A plus probability of A bar equal to 1. Let's say there is a class that there are 20 males and 40 females in one classroom. If you go outside of the class and randomly select one student or call one student to leave the room, what's the probability of person be a male? There are 60 students and 20 out of 60 are males. So probability of person who leaves the room is the male is 20/60, which when you divide is 0.33 or 33%. Or what's the probability of female? Out of 60 students, there are 40 females. So probability is 40/60 or that. So in this case, if you are dealing with just 2 items, and if you already have 1, all you need to do is subtract from 1. So you don't have to do this part if you don't want to. When you find probability of male, which is 1/3, then you could subtract it from 1 to find probability of females. That's what this formula is about. Like here, there are 5 red marbles and 10 yellow marbles in one basket. If I randomly select one marble out of this basket, if I take one marble out of this basket, what's the probability of that marble is color of red? There are 15 marbles into that basket. 10 yellow, and 5 is 15. And out of these 15, how many of them are red? 5. So probability of randomly selecting one marble and that is red is 5 over 15. So in that case, if I want to find probability of the yellow one, all I need to do is, according to this formula, I'll just subtract it from 1. You understand the probability always has to be between 1 and 0. You know, a good example is right here. What's the probability of Thanksgiving be on Thursday? 100% or 1. What's the probability of Thanksgiving be on Wednesday? 0. So probability is always between 1 and probability cannot be negative. You cannot say, what's the probability of rain tomorrow? Negative 30%. That's not correct. Probability has to be positive. Like this example, guessing on SAT test, 1 question with 5 choices. So when I pull, if I randomly select 1 questions out of 5, what's the probability of that question be correct? 1 out of 5. Then when you subtract it from 1, it's 4 over the 5. So if there are 5 questions and you randomly select 1, probability of correct is 1 over 5, and probability of incorrect is 4 over 5. Probability, this part is very important. During this time of the class, when you calculate the probability, if the probability is less than 5%, it's very unusual. So you always want to make sure your probability is not less than 0.5, is greater than 5%. So if it's 50%, then you get a chance, and the probability getting stronger going this way and getting weaker when you get to the 0. Is like this 1 and 0 is 100% and 0%, or this 2. There is an addition rule formula that we see that on the next examples. They call it union. Let me talk about this example here. Let's say there are 2 baskets. One basket, we call it basket A. I have 5 balls in that basket, and then label all those balls as 3, 4, 7, 8, 10. So let's say you have 5 balls or 5 marbles in this basket, and I label them these numbers. And also I have 1, 2, 3, 4, 6 marbles or balls in basket B, and I label them that. What is intersection? This is a symbol for intersection. Intersection means when you overlap these two, what numbers do they both share? They both have 7 and 10. That's what intersection means. You overlap and you see what numbers do they both share. Union means you take all these marbles and throw into one big basket. You just want to make sure that you don't repeat a number more than once. So you take all these marbles and place it into this basket, but if you already have 2 of 10, you just put 1 of them here. So there should not be any repetition of the number here. You should have 1 of each. This is the union, and this is what we use. In algebra, we use this union symbol. And then here we are talking about, look at these 2 events. One has 3, 5, 7, 10, these numbers, the other one on 4, 6, and 8. Do they share any number? Do they have any number in common? No. So intersection of these 2 is almost 0. They call it disjoint. They're completely separated. See, they don't have anything, and you cannot overlap these 2. This is example of, they call it also disjoint events. They are disjoints. But here, since they have a common area, they call it joined events. These two events are joined events. All right. So for this one, for the union, we use this formula that if you have A or B, or A union B, both are the same things, okay? Probability of A or B is probability of A plus probability of B minus probability of A and B. A and B is the intersections, or probability of A union B is probability of A plus probability of B minus probability of A intersection of B, okay? These two formulas are based on these examples. When you have the word or union, A union B, then this is a formula. All right, okay, now I want to go over this problem. In this example, when you see a table like that, what you need to do is first you need to add all the numbers on each row and each column. So the total number is 28. I want to answer the first questions. After having a sonogram, a pregnant woman learned that she will have twins. How many twins do we have here? 12 and 16 is 28. There are 28 twins. It's like you ask all the twins to be in one place. There are 28 of them. How many of these 28 are fraternal twins? Fraternal twins are what? 16 of them. So what is the probability that she will have fraternal twins is 16 out of 28, and when you divide, is 0.57, or you could just say 57%. The next one, physician tell the pregnant woman that she will give birth to twin boys. How many twin boys are they? Look here, boy and boy. There are 10 of them. Boy, boy, 6 of them are identical and 4 are fraternal twins. So you altogether there are 10 twin boys. Out of these 10, how many of them are identical? 6. So it's 6 over 10, which when you simplify is 3 over 5, or 0.6, or 60%. Now C in fact is following this formula. What is the probability a pregnant woman has identical twins, or, see, we are using this word or 2 girls? According to this formula, your A is identical twins, your B is 2 girls. So is equal to probability of A plus probability of B minus intersection. So that is equal to probability of identical twins. How many identical twins do we have? There are here 12 identical twins. They all have the same denominator. You put the total here. They all are 28. The first one is identical twins. How many do we have? We have 12. 2 girls. Girls and girls, there are 11 of them. So it's 11 over 28. And then intersections here. Probability of identical twins and 2 girls. You have to find intersection of these two. Identical twins and 2 girls, okay? So in that case, this is 2 girls, and this is identical twins. So if you go here and here is 6. So you want to find intersection, you come from here and then from identical twins. That would be like that. So this is identical twins and this is Gers and Gers. You see that? That gives you 6. Identical twins and Gers is 6. And then that would be intersections that you put here. So it would be 17/28. And the last one, if the pregnant woman is told that she will give birth to fraternal twins. In this case, she already knows that she's going to have fraternal twins. How many fraternal twins do we have? 16. Out of this 16, you want to have one child of each, means boy and girl. Okay, you have it here and here. 2 and 5 is 7, so that would be 7/16. And this one is also very similar to that. Like, what is intersection of M and N? Means when you overlap these two, see, this is N and M. When you overlap these two, you go from here to there is 0. That's why it's 0. What is probability of M union N? Is probability of M plus probability of N minus probability of M intersection of N. We already know this one is 0. So what is left is probability of M plus probability of M, which is 300/1000 plus 200/1000. So again, this is where we use this formula, the or union. So it's probability of M or N, or you use this union sign. And then here is the example of joint and disjoint. I'm sure when you read this, you understand the difference. When there is no overlap, then it's joint or disjoint. We talk about this one. These are some examples. Here we talk about dependent and independent, okay? So let's say there is a class and this class, there are 6 males and 4 females in this class. Just an example, okay? I'll stay outside and ask one of the students to leave the room. What is the probability a person who leaves is the male? To find the probability, first you see how many students do you have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of them are male? 1, 2, 3, 4, 5, 6. So probability of a male is 6/10. Okay? Now, let's assume that we ask that person to return to the class. So nothing changed. Then we ask for a probability of male again, would be the same, 6/10. So if you want to select 2 students and ask a student to come back to return to the class, then would be with replacement, that person returned to the class. So these 2 events are independent. That means the first event did not impact the second one because nothing changed. Now let's say the first probability is 6/10, right? But this time I ask a student to stay outside. So in that case, if the male is stay outside now, then the number changed. So if I want to call another student to leave the room, probability of male is what? Is not 6/10 anymore. Why? Because there are 9 students left. And out of these, just 5 of them are male. So probability of change. This is V dot replacement. Or dependent. Why? Because the first event impact probability of the second one. When we calculate probability of male was 6/10, but since this student stay out and now return to the class, and we decide to take a probability of male again, this time is changed. So the second probability impacted by the first one. So these two are not independent, they are dependent. That's what the difference between dependent and independent that we normally use with replacement and without replacement. Without replacement means you don't replace it, so the number drop from 10 to 9 and 6 to 5. But the first one, if person return, then nothing have changed, means probability, if you do it for the second time, probability remain the same. And that's what we have here as far as the definition of. See, like here, when a different month is randomly selected and ripped from the calendar. So see, first, you have a calendar, there is a 12 pages, and you randomly pull one page out. What's the probability? That means July, 1/12. But since you take a page out, that page is not there anymore. So when you go for the second time to pull a page out to see if it's July or not, it dropped because now there is an 11 page. So this is an example of two events are dependent because the first event impact the second one. Here also, these two are independent. You know, when a baby is born, what's the probability of the girl? 1/2. Does that really impact the second one when you roll a die? Whether it's a girl or boy, it has no impact on the second. These two are independent. They have nothing to do with each other. So if I want to rule a die, the probability is always 1/6. It doesn't matter. The first event does not impact the second. So this is an example of independent. And these are all examples relate to all this. This is tree diagram. Tree diagram is kind of very important in the statistics. Like, if you want to draw the simple one, let's say we flip a coin. When you flip a coin, you either get head or tails, okay? What's the probability of getting a head when you flip the coin? 1/2. Or what's the probability of tail? 1/2. Okay. Now let's assume the first time when you flip a coin, you get a head, right? Now you flip the coin for the second one. For the second time, you either get head or tails. Probability still is 1/2, 1/2. If the first one is tail and you flip the coin for the second time, you either get head or you get tails. Now we want to look all the probability. If you flip the coin 2 times, you either get head, both times you have head, so you go through this. Or you got, the first one is head, the second one is tail, so it's HT. Or you got tail, head, or tail. These are all the probability or all the possible outcome when you flip a coin 2 times. How do I calculate? You just go through the tree. Is 1/2 times 1/2 is 1/4. They all are 25%. So that's when you flip the coin 2 times and you want to know all the possible outcomes. Now, This is an example of couple want to have 3 children. Up to here is very similar to flip a coin. See? Because probability of boy or girl is always 50%, 50%. But if you go beyond that, see, you have all possible outcomes are this. You have 1, 2, 3, 4, 5, 6, 7, 8 possibility. A couple want to have 3 children. You could all 3 of them be boy. The first 2 is a boy and then girl, boy, girl, boy, and so on. And how do I come up with 1/8? You go through this branch. Probability is all 0.5. 0.5 times 0.5 times 0.5, which is 1/8. See, they all have the same probability. Now, when you have a tree diagram like that, then you could answer some of the questions. Like, the question is this, look, what is the probability of having only 2 boys? You look, you see, okay, you have 2 boys. One is here, 2 boys. There is another one. There's another one. It's just three of them, right? So it's 3 out of 8. Or the question is, what is the probability of at least 1 boy? Probability of at least 1 boy. You see, at least means 1 boy, 2 boy, or 3 boy. The only one who doesn't have a boy in it is right here, right? So you could add all this, which is 7/8. 7 of them have boy in it. It's just the last one doesn't have any boy. So you could just either say 1/8, 1/8 plus 1. You could add 1/8 7 times, or just say 1 minus probability of no boys or all girls. So it would be 1 minus 1/8, which is 7/8. Okay. That is this formula. Probability of at least 1 boy is 1 minus probability of no boys, means all are girls. And the second example is also very similar to that. You just have a different probability. And this is the example of complement here in this one. And then we go to chapter 4. In this, the last section of chapter 4, I think, is the probability. There are 2 types. There is a permutation and combination. One of the main difference between these 2 is for permutation, order is important and order is not considered for combinations, okay? So like here, this is a formula for it. There are 3 letters, right? If order is important, each time when you want to put these 3 letters together, you may come up with the different combinations, right? So it could be ABC, it could be CBA, it could be BAC. How many combinations, I'm sorry, how many ways can you put these 3 letters together? This is order cons. So this is permutations. And this is the formula. 3 out of, you want to take, there are 3 letters available. There are 3 letters of A, B, C available, and you want to take all 3 letters and write it in different orders. There are 6 possible orders. 3 out of 3, which is 6. Or you have combination that order is not important. So in that case, you just have 1 possible. If order is not important, then you just put these 3 letters together. So is 1. Now, here I show you how to use the calculator for that. Okay? What is this sign here? Is a factorial. What does factorial mean? Let's say we have 2 factorial. 2 factorial means 1 times 2. 3 factorials. is 1 times 2 times 3, which is 6. What is 4 factorial? 1 times 2 times 3 times 4, 24. That's what factorial means, okay? So that's how we came up with this calculation. Now, if you want to use calculator will do it for you. See, there are 3, n is 3. There are 3 letters available, and you want to take all 3 of them. So you have to use, for permutation, you use this NPR. And for combination, you use CPR. And this is how to use it. For instance, here, your N is 3. There are 3 available letters, and you want to take all 3 of them. So R is also 3. So on your calculator, first you type 3. You type 3 first. Then you go to math here, math. And scroll to the right, PRB. And then NPR. You type that. So 3 out of 3, R is 3, see? And enter. They give you that 6 that you have here. This one is what? Is 3 out of 3, but is combination. So in this one, you go to, again, you put 3, then math, go to probability, go to combination, NCR, and put 3, see? And that should give you 1. It's very handy for some problems that you're dealing with a large number for factorial and stuff. It's very, very helpful for those problems. Something wrong with my, sorry guys. Like this problem here. There are 5 letters available, and you want to take all these 5 letters and write it in different order. So it's permutation. Order is important. And how you come up with this 120? It shows you type 5. This is, I'm sorry, this is for this example. I showed for this. For this example, you want to take 3 out of 5. There are 5 letters available, and each time you want to take 3 of them and write them, you know. And order is important. How many way can be written? You type 5, then math, and then PRB. I forgot to put that between these two. NPR, you should get 60. If you get 60, then you understand that you're using it right. Okay, so these are all examples here. See, I have this one, so how to use the calculator for that. And this is an example of this formula. When you have you have 10 questions here, 2 of them are same and 3 are identical. The formula is different now. You have N1 and N2. So if you go through the rest of these, I think kind of understand. This is permutation rule. This is another formula, is another permutation rule formula, because you have more than one N, N1, N2, N3, see? It's very interesting for a problem like this. There is a survey, 10 questions, 2 of them are the same, 3 questions are also identical. How many different arrangements do they have? or this one is for the letter of Mississippi. How many S are in Mississippi? Is 4. How many I? 4. You write it, see? And that's how to use the formula. Okay? All right, so if you read all the notes in chapter 4, please let me know if you have any questions. And as I said, we could always arrange a meeting, the Zoom meeting, so I can explain it to you. So that would be end of chapter 4. Thank you.